Hello guys, in this video we are going to discuss the solution of the problem root to leaf paths. So let us look at the problem statement. The problem statement says that given a binary tree of nodes, you need to find all the possible paths from the root node to all leaf nodes of the binary tree. So for instance, if this is the binary tree which we have, then the possible paths or all the paths from root to leaf are 1 and 2, 1 and 3. So these are the two paths which are there, and that is what we need to print. Similarly, in the second example, the paths from root to leaf are 10, 20, 40, which is this, 10, 20, 60, which is this, and then 10 and 30, which is this. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of the problem, let us take a tree. So let us say this is the tree which is given to us. So what we are going to do is we are going to take a path variable, and this is a list, and initially this list is empty. And then we are going to take an I counter, and the initial value of this I equals to 0. And then we will start from iterating from the root of the tree. So over here I equals to 0 and path as of now is empty. So as soon as we realize that the node is not an empty node, then what we are going to do is we are going to update this entry in the path list at the ith position. Okay, so over here as of now the list is empty, so at the ith position, which is 0, we are going to update this node. Now we will move to the left and right part of the binary tree. While moving to the left or right part of the binary tree, we are going to update our I by 1. So now I becomes equals to 1, and over here also I becomes equals to 1. So over here, let us say we are at this position. Again, we see that this is not an empty node. Since this is not an empty node, then I equals to at 1th position, we are going to put this entry in the path list. So let us put 20 over here. Moving forward, again over here, since we are moving to a lower depth, we are going to increase our I by 1. So I becomes equals to 2 and I becomes equals to 2. So now what we are going to do is we are going to put this entry over here. And as soon as we realize that this is a leaf node, so for instance, when we come over here, we realize that this is a leaf node. Then since this is a leaf node, then what we need to do is we need to append all the entries from 0 to I, right? So in this case, 0 to I, all these entries need to be appended to answer list. So let us say we have an answer list, which is a list of list. Over here, what we are going to do is we are going to append all entries of path from 0 to I. And why from 0 to I, it will be clear in a bit, but for now let's proceed with the assumption that we need to append path into answer list from 0 to I. Okay, now moving forward, so now after iterating on 40, our pointer will come to 60. Now here also I equals to 2, so we are going to update our second, which is this, to 2. So let us do that. So now over here, what will happen is the path variable or the path list will look something like this. And since this is also a leaf node, so we need to append this data in the answer list. So initially our answer list was containing this information, which is 10, 20, and 40. Now after hitting the second leaf node, the data will contain 10, 20, and 60. Moving forward, our pointer will come to this position. So we will go ahead and update the ith entry of path list to 30. So let us do that. So remember, the last entry of path was this. So now the ith entry will be updated to 30. So 10, 30, and please note 60 was already there. So 60 will also be present in the list. It is just that we have updated this entry. After updating this, we realize that this is also a leaf node, because of which we need to append path to the answer list. And over here, we want to append only 10 and 30, right? Not the 60. This is the reason why over here, when we are appending path to answer list, we are appending it all the way till I only. So I hope this logic is clear by now. So that's the general idea for this problem, folks. Now let us discuss the pseudocode for this problem. So root to leaf is what we want to do. Root is given to us, and let us say there is a path answer list, or there is a path list which we are maintaining. Then there is an answer list which is a list of list, and then the ith counter, where at which position in array we need to update the entry. Now the first thing which we are going to check is whether this is an empty tree. If this is an empty tree, then we are simply going to return from this function. Otherwise, we are going to update I into path. So now let us update the ith element of path list. So it might be possible that I does not exist in path. So for instance, path initially is empty, right? And we are trying to update the 0th, and I equals to 0. So we are trying to update the 0th element of I. Now since over here 0th element does not exist, so in such case, rather than updating it, we will append it. So that is what I'm going to do over here. If I is less than len of path, then that simply means I exist in path, in which case we can go ahead and update the ith element, and this will be set to root.data. Otherwise, that element itself does not exist, because of which we are supposed to append it. So let us append it. Having updated in the path list, we are going to check whether this is a leaf node or not. So if this is a leaf node, then the left and right child will be equals to none. So if this is a leaf node, then all the data from 0 to I in path needs to be appended to answer list. So let us append it. So answer dot append all the entries of path from 0 to I, and in this way we will be able to append it to the answer list. And then we will move to the next elements of the binary tree. So let us move to the next element. Root dot left, and path is there. Similarly, answer is there. And then now since we are moving to the next depth, so I will be increased by 1. Similarly, for the right part of the binary tree, so root dot right, path, answer, and I plus 1. And in this way we will be able to update our answer linked list, and this is what we need to return. So that's the pseudocode for this problem, folks. Now let us see how we have implemented this in Python. So the implementation in Python is pretty much the same. So this is the main function which we wanted to update. So we took an answer list and a path list, then root to leaf is what I'm calling. Root is there, path is there, answer, and I equals to 0. Now over here, the first thing which we are checking whether this is an empty tree. If this is an empty tree, we will simply return from there. Otherwise, if I is less than len of path, which simply means I exist, because of which we can go ahead and update it. So we are updating it the ith element by root of data. Otherwise, we are appending root.data in the path list. If this is a leaf node also, then in such case we need to append path in the answer list, and this is how we are appending it. Then towards the end, we are iterating on the left and right part of the binary tree. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.